we combine radical expressions by using the distributive property. Here's our first problem. Let's combine or simplify 3 square root 5 plus 4 square root 5. Now we see that the square root 5 is the same in both this term and this term, so applying the distributive property, we have 3 plus 4, that quantity, times square root 5, and then 3 plus 4 is 7 square root 5. So we combine radical expressions in much the same way that we combine similar terms. Now I'll call these similar radicals because it's the same radicand and the same index here. They're both square roots, and what's underneath is 5. If those are exactly the same in both expressions, then we combine them by simply adding these coefficients. 3 and 4 is 7. Let's look at another problem. Here I want to combine or simplify this expression if I can. Now I see I have square root 48, square root 27, square root 75. I can't combine them the way they are. Maybe I'll be able to do it if I put each of these radicals into simplified form. So let's start by writing square root 48 as square root 16 square root 3 minus 3 square root 27 will be square root 9 square root 3. So I'm writing my perfect squares outside here. And 2, let's see, square root 25 square root 3. So now I have 4 square root 3 minus 3 times 3 square root 3 plus 2 times 5 square root 3. And this is probably more steps than you want to show on a problem like this, since you're probably pretty good at simplifying these radicals right now. Now you see I have the same radical in all three expressions. I'll apply the distributive property. Even if I don't write this, this is what I think. 4 subtract 9 plus 10, all that times square root 3. Now 4 subtract 9 is negative 5, plus 10 is positive 5, square root 3. So positive 5 square root 3, that is the simplified version of this original expression right here. Now what we want to do is work another one of these type problems. This one involves cube roots. Let me give myself a little room here. I'm going to write this as b. Cube root of the largest perfect cube that divides this expression will be 8a cubed. What's left in there when I factor that out will be 3a squared b. To that I'm going to add, this is the plus sign, 3a. Now I'm going to take the largest perfect cube I can find out of here. That'll be 27. Let's see, b cubed. What's left inside there is cube root of 3 and what, a squared b. Okay, so here I'm going to have b cube root 8a cubed. When I take the cube root of this, I'll have 2a times b will be 2ab cube root 3a squared b. Plus, that's that addition sign right there, cube root of 27b cubed will be 3b times 3a will be 9ab cube root 3a squared b. So now you can see I have similar radicals. I can combine them. 2ab plus 9ab will be 11ab cube root 3a squared b. So that's the simplified version of this original expression right here. And I know if I can combine these radicals after I've put them in simplified form, because putting them in simplified form gets any unnecessary factors out from under the radical. So what's left, you can see if they're exactly the same. If they are, we can combine them using the distributive property. Here's one last problem. Square root 2 divided by 2 plus 1 divided by square root 2. I want to see if I can add these. This is in simplified form, but this isn't. So I need to rationalize this denominator. I'll multiply by square root 2 over square root 2. Now we have square root 2 over 2 plus 1 times square root 2 is square root 2. And then square root 2 times square root 2, square root 4, which is 2. So if I use the distributive property on this, I would have 1/2 plus 1/2 times that common radical that they have, square root 2. 1/2 plus 1/2 is 1. The answer to this is just square root 2. So here, square root 2 over 2 plus 1 over square root 2 turns out to be just square root 2. So that's a look at combining radicals.